Only one person. Well, good. Let's get started then. So today is basically going to be like a review day. So let's start by taking questions from you guys from homework assignments. You guys have had a good number of them from this chapter. Maybe you haven't done all of the chapter 2 homeworks yet because you got a couple last time, but you should have hopefully at least looked at them a little bit. And we'll do that for, 30 minutes or so, or until you guys run out of questions. And then we'll talk a little bit about the test format. We'll take a homework quiz, and the remaining time in class I'll leave for you guys to work on the review or ask individual questions if you have any. Sound good? Okay. Who wants to start? Again, feel free to take out your tablet or your notebook or whatever you need to look at your homeworks, because I don't know about you, but as a student, I couldn't remember how to do without looking at it. So you're more than welcome to take any of that stuff out to look at so you have some point of reference. Who would like to start? Who has a question? It can be super specific homework question. It could be something general. Anything is on the table. Joe.
I have a question. It's like a general question about solving inequalities.
Okay.
So when you branch them off, talking about, so obviously one side you keep the same, and the other side you change change to a negative or to a positive. That's probably negative. You flip the inequality sign when you do that?
Yeah, okay. Exactly. So you have a situation like this where you have the absolute value, some stuff is greater than some other stuff. So we split it up, and one inequality is just going to be exactly the same, just without the absolute value. And the other inequality changes direction, and the right-hand side gets negated. So these two things always happen in the same inequality. So the one that we negate the right-hand side for is the same one that gets the inequality symbol changing direction. Yep. So that was a pretty general question, but happy to answer those things. Again, an important point, right, to remember to do that. It makes it important that you're able to do the procedure correctly, and that's an important part to the procedure and to touch up on, and that's certainly the right kind of thing to be asking here. Who wants to go next?
We do number 1 on homework 2.
Absolutely. Yeah, number 1 on homework 2. You just grab the page. So this, we ask you to do a couple of things. So the first thing, it asks you to identify the values for A, H, and K. In order to do that, I'm going to use the general form for an absolute value function, which is this. And I'm going to use that then to identify where the A, H, and K are, just kind of visually by looking at my equation. So if I take a look at this, I have y equals x plus 3. So I notice that there is nothing out front of my absolute value. So I notice the A is being multiplied to the absolute value. So if there's no number there, but it's a multiplication problem, what number do I know is actually there? A 1. So I know there's really kind of a 1 there. And then I also notice that there's no there's nothing being added or subtracted inside the absolute value. So if there's no number written there, what number do we know is there? 0, because it's adding or subtracting, right? So there I can see, hopefully it's easy to see that A is 1, H is 0, and K is 3. Joe, are you okay with that?
Yeah.
Okay. So now if I'm going to describe this transformation in words, I need to reference that list of criteria where if A is greater than 0, I do yada, yada, yada. So the A does two things. It does a reflection, and it can do some kind of vertical dilation, either a stretch or a shrink. So for it to do a reflection, it has to be negative. My A is positive, so there's no reflection going on. You could write that down, but I don't require you to do that, to write it if nothing is happening. So you could just skip writing that. To tell if there's a dilation going, I have to look at the magnitude of A and see if that magnitude is either greater than 1 or less than 1. Well, my magnitude is exactly 1, so there's no dilation that happens either. You could write that down, but you don't have to. What? No. Who are you looking for? Emma Roth? I think she's in the honors class. I think their class is 3rd period. You're welcome. Okay with that? So far, so good? The H describes a translation left or right, but since the H is 0, we're not translating any units in any direction, so you don't have to write anything down there. The K is positive. The K describes translations up and down. Since it's positive, it's just going to be translated up 3 units. So you could write up 3 is fine. Or up 3 units, or translated up 3 units. Any of those similar to that is fine. Everybody okay there? Okay. Now to do my transformation, I'm going to use my transformation map. The same one we used last chapter, except here I don't have a value for B. We talked about how absolute values, you don't need to use a B because we can just represent those transformations with the A or the H or whatever. So for mine specifically, since H is 0, A is 1, and K is 3, my transformation map just becomes x comma y plus 3. So basically all that's going to happen is the x coordinate's going to stay the same, and the y coordinate we're adding 3 to. Is everybody okay with what I did there? So I used those 3 points that were given, and I just added 3 to the y coordinate. Come on in, my dude. Check in at the office.
Yeah.
Okay. So I'll just plot my points now. So here's negative 1, 4. There's 0, 3. And there's positive 1, 4. I'll draw my graph. The graph of an absolute value function should always look like a V or a wedge. If you get a straight line, you should know that you've made a mistake. The most likely place where you've made a mistake is somewhere with like a negative sign, probably on this point. Okay. And the last thing we're asked to do is write down the domain and range. Well, the domain for absolute value functions should be easy because they're all the same. For an absolute value function, the domain is always negative infinity to positive infinity. The range, there's 2 possibilities, and we know which one of the 2 based on whether the A is positive or negative. Since our A is positive, we know that the range goes from K up to positive infinity. So in our case, that's going to be 3 to positive infinity. Joe, does that feel okay? Yeah. So of the things we've just talked about here, things that would be a good idea to have memorized, you should have that general form memorized so you can pick out your A, H, and K. You should have this transformation map memorized so you're able to transform the key points. And you should have the rule for how to find the range memorized. So those are the 3 kind of key things that you'd want to have memorized to be able to do a problem like this effectively on the test. Just FYI, the other rule for the range is if it's negative, we go from negative infinity up to K. Since we're reviewing, might as well write down both rules there, right? So you have it all in one place. You don't have to go hunting through your notes to find it. Is that helpful, guys? Again, happy to do this kind of stuff. I think it's important that we spend some time and you get to see some feedback on hopefully questions you've tried to see what's going on. And again, talking about the things that we have to make sure that we have memorized, I think also probably quite helpful. Who wants to go next? Nicholas?
Yeah, can you do number 1?
Number 1 from homework 3? Sure. Just steal the problem. So here we're graphing an inequality. So I'm going to graph the points for the inequality the same way that I did on the previous problem. So I'll start by identifying my values for A, for H, and for K. Doing that, I'm going to be looking at the general form for my absolute value function and comparing that to the problem that we're given. Hopefully it's easy to see that A is 2, that H is 0, and that K is negative 3. I'm then going to use that to write my transformation map. So again, that's x plus h, ay plus k. When I plug things in here, I have x comma 2y minus 3. So the x-coordinate is going to stay the same, but my new y-coordinate I'm going to find by multiplying the old y-coordinate by 2 and then subtracting 3. So that becomes negative 1, 0, negative 3, and 1, negative 1. Everybody okay there? Okay, let's plot those points. So I have negative 1, 0, negative 3, and then 1, negative 1. But before I draw my graph, this is where having an inequality here makes a difference. So when I draw my graph for an inequality, sometimes I'm going to use a dashed line, and sometimes I'm going to use a solid line. So if it's a strict inequality, those are dashed. If it's the or equal to inequality, they're solid. So this one should have a dashed line. Everybody okay there? And then I have to do some shading. So if I have a greater than or equal to, I shade above. And if I have a less than or less than or equal to, I shade below. So in this case, I have the greater than symbol, so I'm going to shade above the line. So that means that I'm talking about shading this area in here. So again, to do this problem, you would need the tools that we had from the previous one, plus the rules for whether you're drawing a solid line or a dashed line and shading it above or below. So this would be something that, again, you'd want to have memorized, the rule as to when you shade and or where you shade and whether you use a solid or dashed. Nick, you feel okay there? Cool. Who's next? Megan, I thought I saw your hand earlier. Did you have something you wanted to ask about? Yeah, sure. Okay. So this problem asks to write the absolute value function that fits each situation. So what it's asking me for, what my final answer would look like, is some equation that looks like this. Right? So we need to figure out a value for A, for H, and for K so that this graph goes through the 2 points that are given. Now, 2 of those 3 of A, H, and K are really easy to get. The key is remembering that the vertex is H, comma, K. So right away we can tell for this problem that H is negative 3/5 and K is negative 7/3. We kind of remember doing that? Okay. This other point I can treat as an X and a Y. So if I plug in the H and the K and the X and the Y into this equation, I can then solve for A. So that's what I'm going to do right now. So there's Y equals A, that's what I'm looking for, X minus H plus K. So far, so good, Megan? Okay. Now all I'm left to do is to solve for A. To do that, I'm going to try to get the A by itself. So I'm going to start by subtracting 7/3 from both sides. But to subtract 7/3 from negative 6/7, I need to have a common denominator. Right? To add or subtract fractions, we need a common denominator. If I look at the fraction 6/7 and 7/3, what would the common denominator be between those two? 21, right? So we'll multiply negative 6/7 by 3/3. And then we'll multiply negative 7/3 by 7/7, because the resulting fractions will have the same denominator of 21. Okay with that, Megan? So when I subtract two fractions, I just subtract the numerators. So negative 18 minus 49 is negative 67. And the denominator stays the same. Are we okay there? Now I should also combine my like terms here. Again, to do this, I'm going to need to have a common denominator. Looking at negative 10/9 and positive, because minus a negative, 3/5, the common denominator between with 9 and 5 would be 45. So if I multiply the first one by 5/5, and I multiply the second one by 9/9, and then I add those two together, I'd have negative 23/45. Okay, there. Now, if I take the absolute value of negative 23/45, that's just positive 23/45, times a, and usually we write the coefficient in front, so I'll put that in front of the a. And now the last thing to do to get the a by itself would be to get rid of that coefficient. So you could divide by 23/45, or what's probably an easier way to think about that is to multiply by the reciprocal. So one thing I notice right away when I'm multiplying is that the 45 and the 21 have a factor in common. They're both divisible by 3. So I can reduce those. And then 15 times negative 67 is negative 1005. And 7 times 23 is 161. And that's everything we need then, right? Right? Yeah. Megan, are you okay with that? Okay. So the fraction part probably makes this a little bit more challenging than if they were just whole numbers. I want to point out to you, though, that you can do all these fraction operations on your calculator, and your calculator will give you a fraction back. So just to walk through what that would have looked like. Can you guys in the back see the calculator screen? Somebody want to stand up and turn off the light for us so it's a little bit easier to see that? I know the black on green is not easy to see when everything is fully lit. Is that better? Okay. So, Megan, remember the first thing we did is we had to do negative 67 minus, or I'm sorry, negative 6/7 minus 7/3, right? So if I wanted to do that on my calculator, I'm going to put a negative sign. And then to make the fraction 6/7, I'm going to press alpha, y equals, and then I'm going to choose this first option. These are all fraction options. The first one is the one you'll probably use the most, where it's just like numerator and denominator. And now I can just type in 6/7 exactly as it looks like on my paper. And I'll do minus, and I'll press alpha y equals, and I'll choose that same option, and then I'll do 7/3. And I'll press enter, and the calculator returns for me another fraction, which is lovely, right? So I don't have to worry about decimals or anything else. It keeps it as a fraction if I use the fractions inside the calculation. And then what did we do? We had to combine this part. So we did negative and then fraction. So alpha y equals, choose that first option, 10/9 minus a negative, and then alpha y equals that first option, 3/5. So there's my negative 23/45. And then the last thing we did is we took negative 67/21, and multiplied it by the reciprocal. So we'll do, I'm going to actually cheat a little bit, and I'm going to go back up there and press enter so I can retrieve that fraction and have to type it in again. And then we're going to multiply that by alpha y equals numerator over denominator 45 over 23, and press enter. And there's my negative 1005 over 161. So if you get uncertain about your operations with fractions, you can always use the calculator in that fraction command, and the calculator will keep everything in fractions for you. You don't have to mess around with any kind of decimal. It'll return an answer for you in fractions. The fractions look exactly like they are on your sheet of paper, so it's easy to deal with. So you can always do that. Does that feel okay? Okay. I had a feeling the fractions were probably what was bothering you more so than the process. So hopefully this felt helpful on how to kind of check that stuff on the calculator. Just use the calculator to do it. Okay. Who wants to go next? Do we have more that we want to talk about? Sure. From homework 4? Okay. I don't think I have 2 on that page, but we'll grab it. Because I only took 1 page. I didn't take the whole homework assignment. But I knew what you meant. Okay. So again, it's Elizabeth, right? Okay. Elizabeth, we're going to start the same way. Our final answer should look like an equation that looks like this. So we're charged with finding h and k. So right away, the first thing I want to do is find the vertex, because that tells me my value for h and my value for k. To find my value for a, I'm going to plug in my h and k, and I'm also going to use the other point to plug in a value for x and y. Now that I have all of that stuff, I have just the a left to solve for. So I can do that directly. We still good there, Elizabeth? Okay. So we'll just add 5 to both sides. That gives us 3. And then negative 3 minus 4 is negative 7. And the absolute value of negative 7 is positive 7. And if I divide both sides by 7, I get that a is 3/7. So if I put that all back together, I have y equals 3/7 minus 4 minus 5. How was that? Was okay? Good. Okay, Joe.
It's another general question.
Sure.
So on homework 2 and homework 3, we're both graphed, whether we were graphing or whatever.
Yep.
So it's the same process for both, except you have an inequality ones that you have to like.
So the inequality, the only difference is drawing your line, you have to check whether it should be solid or dashed, and whether you should be shading above or below. But that's the only difference between the two.
So the process of like finding your coordinates is the same. And all
Yes.
That? Okay.
Yes.
Thank you.
Connor.
Can we like check that answer by putting it into like the graphing part of our calculator?
Absolutely. Yeah, you could absolutely check this by graphing the equation that you found on your calculator and seeing if it matches the picture on your sheet of paper. Sure. So to do that, to graph something, we press the y equals button, and we'll clear out whatever we might have had in there. And then I'll do alpha y equals, and then choose that fraction command to put in the 3/7. And then I'll do times. And then to get the absolute value on my calculator, I press the math button, and go over to the number menu, and I choose the ABS command, and that puts the little absolute value bars in there. So I can do my x minus 4, and then I'll move that over, and I'll type in my minus 5. And then to get the picture, probably the best way to do that is to press zoom and pick Z standard. And what we have there is a pretty darn convincing evidence that we have the correct equation, right? Looks very similar to the location. It's actually identical to the location that we're seeing on our sheet of paper. Does that feel okay, Connor? Yep, so that's an excellent point. Yeah, you can absolutely check these by looking at the graph on your calculator to see that it matches the one in your picture. For sure. Okay. So let's stop here. If you guys end up with more questions, you can always come back and we can talk about those on an individual basis once you guys break to work on the review, if you run into something you want to talk some more about. Let's talk a little bit about the test format. So, like, what am I going to ask you to do and all that jazz? Sound good to you guys? Okay. So we have 4 questions where we're going to ask you to solve an absolute value equation. I have 2 questions where I ask you to solve an absolute value inequality. I have 1 question where I ask you to graph the absolute value function, and 1 question where I ask you to graph the absolute value inequality. That's something in 2 variables. And then I have 1 question where I ask you to model going from graph back to equation. So these guys are questions that would be similar to things on homework 1. This would be something that was similar to a question from homework 2. This one from homework 3. And this one from homework 4. So there's not a ton of questions, but that's okay. Like, some of these questions take a minute, like graphing can take a minute. There's lots of things I ask you to do for those. So the format of those graphing questions will be just like the format of the questions on the worksheets. So I'll ask you to do the same steps along the way. So you've been practicing the whole time. And in general, if we look at the review that I posted for you guys, the review is the exact format of the test. The only difference between the review and the test is, like, the questions will be different. But the format is exactly the same. There's the same number of questions, the same types of questions. So the review is there on the content library. And you'll also see that I've posted my key for the review as well. So as you're checking, or as you're doing this, you can check to make sure you're doing things correctly. Okay with that? Okay. Any final questions about the test here before we move on? And again, if you didn't write all of this stuff down or you want to go back and reference this, this is all in the content library, right? These are just the notes from today. So all the notes are always there. You can always find them on your OneNote, which is nice, right? To know that it's always there. Okay. Up next, we're gonna do a homework quiz. So you're gonna need your tablet open, and you're gonna need your OneNote fired up, and you're gonna want to open your shared notebook. And I am going to copy the homework quiz here into your content library. So I'm going to paste that in there, and then I need to sync. And if you open up the content library in your OneNote, at the end should be homework quiz 2. If you don't see homework quiz 2, try resyncing your notebook because it probably just hasn't caught up to my sync. To sync your notebook, you just go up here onto the notebook name and right click, and you can click either sync this notebook or do the notebook sync and sync all your notebooks. It doesn't really matter. They'll both accomplish what we're looking for. But you should see this homework quiz. It has 3 questions on it. So you'll do these 3 questions on OneNote, and then you're going to publish this OneNote as a PDF, and I'll have an assignment in PowerSchool called Homework Quiz 2 that you'll submit that PDF to when you're finished. If we need to run through those steps again, we can do that in a minute. Yes, sir. It's in the content library on your shared OneNote for this class. You see it now? Good. Yes. So if you do this on a separate sheet of paper, you'll need to take a picture, put it back into OneNote, publish it as a PDF, but that's fine. You can do it on a separate sheet of paper if you'd like. Have you synced? Okay. And then if you still don't see it after a sync, come show me and we'll see what's going on, okay? I am happy to take a look and help out. Now that you guys have had a chance to look at this, on question 3, do the blanks make sense what I'm looking for you to fill in? Okay. Again, if you have a question about something, feel free to come up and ask. I will help you within reason. You know, I'm not going to do the problem for you, but we can certainly help out a little bit. Vanessa, that showed up for you? Okay. I assumed after not hearing anything back that it had worked, but figured I should check just in case. Some people are shy, you know? And just FYI, those of you guys that are big writers, like this is a OneNote file, so if you need more space for your writing, you can just like put your cursor in there and press enter a bunch of times and make more room for yourself. You know what I mean? So I think I saw last time that some of us looked like we ran out of space trying to do things or write in the area. You can always just put your cursor in there and press enter to make yourself more room. I know tablet penmanship varies from individual to individual a little bit. My penmanship looks different on the tablet than it does on like a sheet of paper, so trying to be flexible there. Joe?
For the graphic problem, do we not have to worry about the domain and range?
I'm not asking the domain and range for it. Yep.